Welcome everyone to our first conversation here at CES 2026. It's Tuesday. It's the first day of the event that sets the tone for our industry for the year. My name is Thomas Mueller. I'm your host today. I'm the CTO of Acharya Engineering, and I'm having Shrikant here with me, the CTO of Excelfore. Shrikant, welcome.
Oh, thank you so much. I've been in the industry 22 years, and I've seen a lot of changes. And today, Thomas and I are going to just exchange notes because we travel a lot, we see a lot, and maybe the benefit of our experience can be brought to the audience.
We wanted today just take a look on the industry and how the industry has been developing when it comes to probably one of the hottest topics over the last years, which was software-defined vehicle. Many may argue AI has now, of course, outshined in terms of hype the software-defined vehicle approaches, but we're 4 years down the road in engineering software-defined vehicles for our customers, and we've been working collaboratively, extensively with Excelfore in many of the aspects of SDV. So, Shrikant, I would like to get your perspective, your engagements with customers. Where do you see SDV stand today?
One thing that I always get amused is how many people want to do things differently. And yet, if this is the differentiation, it's a Tower of Babel. And so as a result, a lot of progress which it could have happened never happens. I think until you get a maturity of thinking, it will be very tough to get SDV into a what I call a pedestal where people can actually avail of the benefits of a software-defined area. So now, from me of SDV is what OEMs think and what I think. So the OEMs think that anything they can update becomes an SDV. Now, of course, there is a graduation towards what I call big compute platforms. They can partition it. They can reorganize the what I call the activities and functions, like take the Qualcomm's 8155 and above. This is a first concept, but the majority of the concept is driven towards infotainment. So, unfortunately, it doesn't go beyond. But that is a really good concept. But what is really software defined would be more, I call, narrow today. So, you create a common platform, say, for a drive leveling system. So, the drive leveling system for a comfort vehicle like the S500 or for a Ferrari could use the same platforms, but the configurations are changing. So by changing the configuration, the drive leveling system has adjusted to what the vehicle is supposed to do.
Yeah, Shrikant, we've been on this journey with you guys, and I like your characterization. Having the ability to update software at any given point in time does not constitute even remotely a software-defined product, notwithstanding a software-defined vehicle. It's an essential prerequisite, ultimately, that the 80 plus ECUs in a vehicle are actually talking to each other. And I believe in today's market, if I look at, I got a new vehicle this year, and I can clearly say when updates come through, it only affects a certain amount of ECUs, if not just the infotainment computer itself. This is not even remotely close to a software-defined vehicle. And since your starting point was to provide us with the ability to update software, can you talk us through your ability to standardize how ECUs can actually altogether be updated, and then from there on how the capabilities of communication, we're dealing with decade-old industry buses, is evolving right now? I'm a telecommunications guy historically by education before I joined Wipro. And coming to the auto industry and dealing with serial buses with bus speeds that are beyond what I could imagine in today's age was kind of baffling. So what do we see as an opportunity in pertaining to your technology that really gives us both together an edge? How does that come together?
So when we started to design OTA, my first experience was with Visteon. Remember the smart core of Visteon?
Yeah.
If you remember?
Yeah.
Right? And I talked to Visteon and said, if I give you something, you will never adopt it beyond this smart core. Why don't I give you a spec and you modify it? Because what I really wanted was somebody in the industry to own it. and not be something we create as startups quickly from A to B, but more for how do you actually be regenerative? That's a very key for standardization. If it's not regenerative, a stagnant thing doesn't work, right? So, but of course, we learned from it, and then amazingly, about 2017, we had 5, 7 companies came to us with requests for these updates, but each had a different format. If I can convince them that a one format of a pipeline would work, then that's actually a progress for me. I can handle all 5. So I proposed to them is that we will create a document and we'll all implement the same thing for you. If you are agreeable, I'll put this into a public repository. And that's the start of how eSync has started. So now, where has it gone? So first, if you talk to OEM, they say yours is a proprietary thing. So that's the first hint of what I call how the walled garden approach, right? Anything outside is not something to be interested in. So how did we proceed? Standard has 3 problems. One is it has to create an open spec worth adopting. Then you have to have adoption. And then you have to have robustness to prove the case. So you have enough things to prove even before standard actually comes what I call into force. So as the early what I call creators, it was a challenge. And I had talked to Zeraf and I talked to Hela, but each one is coming with that narrow thought process. So really, as a systems purpose, my first thing was which group wants such a thing, and China was the answer really. And I really like for that very reason why China is so far ahead is that the shoot first philosophy, then figure out what falls out, right? And so to put a standard together, we found them to be willing acceptors. I mean, I couldn't do it in Europe. I couldn't explain it. Couldn't do it in US. And that's a challenge for all of us. But now what has happened is Sophie came along. They wanted containerization. So now the original OTA became a containerized OTA. Then ASAM with SOVD came and they said, yeah, that we should actually harmonize the APIs so that SOVD can come over to eSync and eSync can come over to SDVs. Now, if you look at it, no company would in the right mind would do all of these what I call forays because it's not reflecting in the P&L. The ROI doesn't reflect this investment. And that's why standardization is so effective is that it doesn't have these kind of what I call boundaries to act. It just goes where people want it to go. And so it becomes regenerative. And to me, that's very important. But if I look at it today, 15 OEMs have eSync in it. It's very robust. It has been broken down enough that it can be absorbed by partners like Wipro, and you can run your own business on it. It doesn't. So I'm not holding you back in information or direction, and I think that's how ecosystems flourish. And to me, it's all about ecosystem. I don't want our company to be in front because I have nothing to gain, but I want you, Wipro, to be up front because that helps us. So to me, that's what drives me is how do you make Wipro stand out? That's all I think.
I like that analogy, Shrikant, a lot. And since this is all about, differentiation, progress in innovation for our customers, it happens through standardization. Before I, built our automotive practice here back in 2021 at Wipro, I was leading our network engineering and heavily invested into specifications and standards like all-round for the standardization of radio access unit, which used to be highly proprietary, complex products, and the opening up to a few standards actually opened up an entirely new market that was unthinkable, maybe 8 or 10 years back. And that led to a lot of innovation in this from a hardware, silicon perspective, from a software perspective, platform perspective. And I think the automotive industry is now really facing the challenges. We've seen development cycles in some instances drop in the auto industry to less than 2 years. I know I've seen a lot of the Chinese OEMs who turn around new products within less than 2 years, 18 months perhaps, even though, and I think the best in class in Europe is Renault at the moment. They dropped the new Clio to 2 years development cycle, which is fairly impressive, very impressive. But in order to do that and to avoid reinventing same things over and over, I think the standardization that you said is absolutely imperative. One of the reasons we invested into SDVs, which we also have here at the show, was that we believe in a free interoperability of software component across the compute platforms in a product like a car, or for that purpose in a truck or a vessel or a bike. They all have distributed compute with different applications and apps and workloads, and because of the nature of them being embedded, it was hardly possible to basically make any changes to these systems without having to go through very comprehensive and expensive testing cycles. And now, spinning this up also to the other capabilities of Excelfore, I think you guys given us some key components for communication, such as time-sensitive networking, like precision time protocol, that are all infrastructure building blocks when it comes to standardization of a vehicle compute platform, which is the foundation for all its applications, including AI. When we want to make AI real in a vehicle today, we can't make that real without having the computational foundation. And historically, with embedded systems, the computers were often too small by the time that the product came to market already, and they're not field upgradable either. So how do you build a product like a car that you can keep digitally relevant for 10 years? That was one of the challenges. Maybe if you could elaborate a few of your contributions on that journey, how can we keep a car digitally relevant for 10 years using your approach with Excelfore and your partners, the ecosystem?
So I think two things. I want to always say it is the eSync approach, not Excelfore approach, because that makes that, kind of makes it very limited. And I really think what we discover goes back into the specs. So always the specs is getting enhanced, right? One of the things I always tell customers, what is your monetization schema? Is it the pipeline or the applications? And I will say, if I split that way, they say the applications. So why do you spend time re-engineering the pipeline? And the pipeline continues to get patched up, so it never gets to evolve into this, what I call adaptive and really reconfigurable pipeline. So if you can clearly carve this out as standardization of the pipeline, it doesn't change anything for the OEM. Their customers don't change. The apps are the ones that distinguish who they are. It's like your face is what people see, not the body and the parts. When those are standard equipment, as they say. So similarly, in the case of OTA, the pipeline itself is a big problem to standardize. It needs to be robust, it has to be error-free, it has to address cybersecurity, it has to address security concepts that are kind of changeable depending upon the customer. And so if we cannot address that comprehensively, then we are all failing in the job.
We all seen throughout 2025 some impressive video footage of how robots in different shapes and form, whether they are leg robots like humanoid robots, whether they are having wheeled or even drones that fly. Robotics is a hot topic. Embodied AI, physical AI is the market where products that are potentially impacting the safety of a product are becoming real or more real as we speak, and our investments in innovation go into that direction. And I'm curious on how you see your contributions to the embodied AI market, because I believe there's potentially a lot of similarities to what we see in cars and how cars learn to be operated in an automated fashion. The tag word is ADAS, driver assistance technology, level 2, 2+, 2++, level 3. And how we get to those systems, it's, I believe, a key for monetization, to build those basically harvesting solutions that can harvest data at the scale of a fleet, of a product that senses its environment, continuously produces potentially gigabytes and terabytes in data through its use cycles, and how we handle that data and your contributions to this type of innovation that is now right here.
That's a great point. Two things are important. It's all about mathematics in the end. So the mathematics is, if you're flowing too much data, you have to compress it. Right? So you have to remove as much redundancy as possible. Now redundancy can be removed through what I call removing the repetitive instances and coding them. That's the classic redundancy reduction. But the other thing is, not all data is relevant, right? So you want to bring some domain-specific models that look for changes, and only the changes get reflected back. That dramatically reduces how each pipe gets engaged. So you can now multiply the number of devices that are communicating in that manner. And I think, but the challenge with AI is it's expensive, and so that expense ultimately becomes a bottleneck for consideration. So I believe where the growth would be that the models have to become extremely constrained for it to reside in a compute environment that is cheap to be put in a robot, and it should do very specific things.
I agree. I mean, we see it in the automotive market, especially in passenger cars. ADAS technology, unless it's legally mandated, is an option. It's optional. That means the infrastructure to run it, the inferencing compute, the sensors, are not fully equipped with every vehicle. There's a few notable exceptions in brands. We all know, that Tesla has a very common sensing and compute stack in all of its vehicles, regardless. But most OEMs cannot afford, do not want to afford, basically a common sensing and computational stack that would enable the edge AI to be ubiquitously available. So they have to support a heterogeneous contributions environment. Some cars contribute more data because they have more sensors and they have different types of sensors, potentially including, radar and LiDAR, and other cars don't. So the normalization across these contributions becomes yet another challenge in your data flywheel, as we simplified call it these days, which is basically the RL, the reinforced learning cycle that has to be built between an edge product and a trained model that gets redeployed and allows the physical AI basically to understand what it sees and how actions are being, derived from this in near real time. So how do you, looking practically at these challenges to standardize and normalize these models across a heterogeneous fleet, what would be your best guess is going to happen in the next 3 to 5 years? Will OEMs be willing to chew up the extra cost of hardware in exchange for a standardized contribution of our products? Or are they willing to continue with a heterogeneous approach and then potentially be not able to clean the data up and normalize the data in a way that they can create those really value-creating models for them? I'm undecided because I see products in both ways. We've seen Rivian, for example, in December, announcing their data flywheel approach on how they want to achieve autonomy across their new generation of vehicles, which is very similar to Tesla, as we can say. But then there is other brands who have a much wider portfolio of products, also aged products, where it's questionable if they can ever contribute in that. And where this is going, we've seen GM also announcing their plans for 28, to move to the next level of advanced assisted driving. I'm curious how you see this with your experience in the OEM industry, how they, will take an approach.
So Rivian, Tesla are not really car companies, in my opinion. Comparing them to the likes of GM and all that is actually not exact. It's not apples to apples comparison, right? First of all,
but still the products that they're selling, from an end customer perspective, they're competing around the same $400 leases for their vehicles, or $500 leases, whatever it is. So it's in the same segment.
I agree. So I look at Rivian, they created their chips, right? I know personally for the chips of that size, how much is the investment needed. I cannot fathom OEM spending that money. So obviously some investors' money has gone in. Running corporations don't have that kind of flexibility.
Well, they can work with Wipro on designing those chips. We can help out with that part.
That's true. So, think about it is, I call it graduated acceleration, where you set your sights at a level that you can achieve and achieve it. Don't be too, what I call anticipatory in terms of, I can create this. No, you cannot, because you're not that kind of a company. You have 20 car platforms. You literally cannot collapse them into 2 car platforms like Rivian or Tesla, right?
Yes.
So that challenge will never go away. And so the idea that everybody can graduate to that level is not not really something we should look forward to. But incremental improvements are happening, which is what the public wants to pay. See, public, it's also the paying public, right? So they all have to look at it. I'll give one example in the phone world. Apple has never, in my opinion, the Siri sucks today, right? In fact, it stopped even. I mean, when I try to dial Srinath, it dials my son. So to me, it has degraded. But I think Apple is waiting for the AI thing to figure out. So, but they have such massive compute platforms. To me, that's the kind of how I believe our traditional OEMs looking at this whole process, because they cannot sustain that level of investment. But they would like to gain the advantage by adopting it when it's mature. So I think this is the dichotomy that traditional OEMs face: when to invest and when to not.
Yeah, sure. Okay. Do you see an opportunity that the in-car models, the in-car, we call them small language models, for example, that can be, locally inferenced, that can be locally executed on vehicle high-performance computers, that those models will start seeing much larger traction for either the aspect of user experience, latency, real-time hardness, or also cost savings? Because obviously, using cloud-hosted models comes at a cost. The API use, has its cost. Do you see the adoption happening of local language models in products like vehicles at an increasing pace, and such a requirement to have more frequent software updates that are orchestrated smarter because the amount of data that gets transmitted is potentially much higher? We discussed maps updated being big, but potentially model updates are much bigger than this. Do you see this as a realistic scenario to happen in the next 2 years?
Actually, I can give you one instance where it is very practical to have it. So traditionally, when you buy cars, you had this fat manual, but they got rid of it. You had to go and purchase a manual. Then the manual became online, right? And then they gave you a CD that you can. All these are clunky, right? Because the information is vast, and how do you narrow down to that problem? So, very good example. You create a small language model and ask him, "Oh, I have a red light, or I have this code coming up. What is the problem?" That creates the interaction with the vehicle and makes it very sticky. I think that's going to be tremendous.
Yeah, I can't wait for my yellow engine light that comes up regularly to actually tell me what's going on.
Exactly, and I think to me that is fundamentally where I think the value proposition is very high for OEMs, is to make this small laser around their car, and so the car becomes interactive, and suddenly it feels like a person. Yeah, like the phone. So I think to me that is clearly a plus for the OEMs to enter. But I'll tell you one thing about models. Models can digress. And so you think you're doing great, but a model is contracting, and a new data set, and it just flies off. And you just spent $20,000 doing the model, or even $100,000. And that's a challenge for investing in AI. It has to have lots of data, otherwise it hallucinates, right? So it's a existential problem as to how much AI is really needed.
I'm a big lover of good user experience. And unfortunately, in the automotive industry, I way too often come around too many examples of not so great user experience. And mostly pertaining to how your cockpit, how your cabin is built around you, how the digital processes are thought through, and how, for example, also, additional components like your mobile apps can be used in conjunction with your product. Ultimately, I put it in short, my car, even until this very day, does not get me. It doesn't understand properly my context, doesn't properly understand my intents, and as such, it feels there is a distance between me as a user, between me as a driver, or in my role as a passenger, and the product. As a passenger, a simple example is, when I look at my digital real estate, like a big screen in front of me as a passenger, where the OEMs offer this as an expensive feature, that screen does not give me any contextualized information about what I'm really interested in. So ultimately, I pivot and pull out my smartphone and do what I have to do, but that screen is basically wasted money in front of me. It is all cases that I have seen so far. So I'm wondering how, together with what you are driving as innovation with eSync and others, how do we get to a product like a car that really understands me better?
Simplifying the necessary outcomes to the consumer, which is the garbage time, is where the challenge is how simple, because the car has become increasingly complex and more digital data in front of you will confuse the grandmas of the world. And so at some point, even us who are technologically involved will reach a point where we will stop consuming that amount of information. But yet we need some critical information to pop up. And that's going to be a key in defining which car actually succeeds in that process. I mean, I used to see the Ford Sync. Man, it used to take a lot of time to figure this one out. And I was wondering why it makes these things so complex. Technology doesn't have to be complex. And I wanted to address one thing. The collaborative engagements that Wipro and Excelfore do is largely depends upon what customer use case is. Now, for example, I was actually in Japan, and I think you had brought me a reference, and I talked to your salespeople, and they were kind of wondering how to present. And this is where Excelfore and Wipro being eSync partners, that is the kind of camaraderie that needs. That's a village, right? It's discussing problems. So we actually created a presentation, and I spent 8 hours telling and teaching it the workforce, and after that I was gone. And after that it was all Wipro. So I really like it. And then I think one particular real use case here in ATS. So this is, I think it's intriguing that ATS can be the lowest cost dispensation of information in a cycle. You just have to trap the information, figure out where in the cycle the information is, and wait for it to fully complete and dispense. That's another place where we are doing lead technology development. I think this is, and technologies are complex by nature, and one company just cannot do it. Yeah, that's right. So I think to me, those are real great points as to why I think we are collaborating.
And at this point, thank you so much for joining us here at Wipro Intelligence at CES 2026. Shrikant, big shout out and thanks to you. I want to thank you for the partnership.
All right, absolutely.
Our most companies, and I look forward for a successful year.
Absolutely.
Bye.